Hello students. In this video, we have a list of 9 parent functions and their properties. So it's good to know the picture or the graph of each function and the properties of each one of them. So let's look at the functions. The first one is the linear function y equals x. You know the equation of a linear function y equals mx plus b. The y-intercept for this function is 0 and the x-intercept is 0. Now, properties. We're going to talk about domain range, x-intercept, y-intercept, symmetry, even, odd, or neither, increasing, decreasing, and I will give you some time to go over these and then we will answer the questions together. So these are the properties of this function. The domain is all real numbers. The x and y intercept are 0, 0. It's an odd function, so it's symmetric according to the origin, and it increases over the interval negative infinity to infinity, over the entire x-axis. This is the absolute value function. It's a V-shaped function. It has a certain domain and range. So let's look at the domain and range. Alright, stop the video and answer the questions. Then I will show you the answers together. Alright, these are the properties of the absolute value function. You should be taking notes while watching this video. So this function is an even function. It has y-axis symmetry and it increases over the x-axis on the positive right here. It increases on the positive x-axis and it decreases right here. So that's the negative part of the x-axis. Let's continue. This is the quadratic function. The shape of its graph is a parabola. The equation is y equals x squared. Again, stop the video and take some time to answer the questions. The quadratic function y equals x squared, it has a y-x-intercept 0, 0. It is an even function since it's symmetrical according to the y-axis. So if you try to fold according to the y-axis, fold the function, that you will see that the two parts will coincide. I'm talking about this part and this part. It decreases right here, which is negative infinity to 0, and increases from 0 to infinity. This is the square root function, y equals root x. We call it the square root because the x is inside the square root. Remember, under any square root, if we have a negative, that will give us a non-real number. So you see there's nothing here on the negative side of the x-axis because the square root of a negative is a non-real number. Go ahead, draw the picture of the square root in your notes and write down the domain range. Stop the video please before we answer the questions together. So I'm going to give you some time to go over these questions and then you can check your answers with me. All right, this function has a domain and range 0 to infinity. The y-intercept and the x-intercept are 0, 0. There's no symmetry, so it's neither odd nor even. And this function increases from 0 to infinity. It's always increasing. It doesn't decrease. The cube root function, the cubic function. That's not a cubic root. Y equals x cubed is the cubic function. They have this shape. You will see some polynomial functions with a degree 3 or an odd degree like 5. They all look alike. Draw the function in your notebook. And let's talk about the properties of this function. Again, stop the video, write down those questions, and I will stop my video now so you have some time to answer those questions, and then we can check together. You can check your answers now. This is an odd function. It's an always increasing function. This function never decreases. This is the cube root function. Y equals third root of x. The variable x is under the cube root. Now we don't have any restrictions under the cube root, so I can do the cube root of -27. The cube root of -27 is -3 because -3 cubed gives me -27. So there's no problem having a negative under the cube root. The domain range, x, y intercept. Write those questions again. Stop the video, please. Answer the questions, and then you can check your answers. You can check your answers now. This is again another odd function. It has origin symmetry. X and y intercept 0, 0. Domain range is all real numbers. And this is an increasing function. It increases, it never decreases. It increases over the entire x-axis. This is a rational or reciprocal function, y equals 1 over x. We're going to graph those functions later on in the year. This function has asymptotes. We're going to talk about that in details later on. So y equals 1 over x, it's called a rational or reciprocal parent function. So it's rational, reciprocal parent function. It has two branches. So the graph has two parts. You draw one branch right here. This is the behavior of this function. And then there's another branch here, y equals 1 over x. Again, stop the video, write down those properties in your notebook, answer them, and then I can show you the answers. All right, this function has a domain of all real numbers except 0. So 0 is not in the domain, and also 0 is not in the range. So the domain, I wrote the domain. I can also say x is not 0. That's another way of writing the domain. For the range, I can say y is not equals 0, or I can just put it in interval notation. X and y intercept, there's none. The function doesn't pass through the x or the y axis. This is an odd function. It has origin symmetry. And this is a decreasing function. So from left to right, this is decreasing here and decreasing here. So it decreases from negative infinity to 0, not including 0 because 0 is not in the domain. And also decreases from 0 to infinity, right here. Don't include 0 because 0 is not in the domain of this function. Exponential function, y equals b to the power x. X is in the exponent, and this is a growth function. It could be a decay function. So we're going to talk about an exponential growth here. I'm just going to give an example of this exponential function, y equals 2 to the x. It could be y equals 3 to the x, half to the x, 7 to the power x. So the base could be any number. It could be a fraction, or it could be a number larger than 1. It can be a negative though. Again, stop the video. This is the graph of y equals 2 to the x. All of those y equals b to the x, they look alike. If it's a growth function, it could be a decay function. In this case, it's going to go something like that. That's a decay function. It decreases. So let's talk about this growth function now. Write down the properties, answer the questions, and then you can check answers. Please stop the video for a couple of minutes to answer the questions. So this function has a domain, which is all real numbers. Range is 0 to infinity, not including 0. I have a y-intercept right here, but we don't have an x-intercept. There's no symmetry, and the function is increasing from negative infinity to infinity. It's a growth function, so it's always increasing. The last function is the logarithmic function, y equals log base b of x. And it is the inverse of the exponential function. We will graph those functions in the spring semester. And let's take an example. Y equals log base 2 of x. This function is log base, y equals log base 2 of x. This is the shape of the logarithmic function. Again, this is y equals log base 2 of x. It could be y equals log base 3 of x or log base 4 of x. So I just took an example and they all look alike. Again, write down the domain, range, and all the other properties. Answer the questions, and then we can check together. Please stop the video. Alright, this function has a domain 0 to infinity. Notice that it's on the positive side of the x-axis, not including 0. There's nothing at 0. Actually, this line here, which is the y-axis, we call it a vertical asymptote. Now the range, the range is from negative, on the y-axis, it goes from negative infinity to infinity. It doesn't have a y-intercept. The x-intercept is right here. It's not an odd or even function, so there's no symmetry, and it's an increasing function over 0 to infinity. There's nothing on the negative, remember? There's nothing on the negative infinity or on the negative side. It is good to remember those functions and their properties, everyone, and their pictures. That is very helpful when we graph some of those functions.